Cool. Hi, everyone. According to StreamYard, we are live now. So I'm just gonna take StreamYard at its word and then assume we are live. So Justin usually kind of runs the technical side of things. So I am a bit kind of out of my comfort zone. He is unable to do tonight, so I'm going to be kind of running this mostly solo. So be patient with me. So tonight we're going to talk a bit about Elm. Gary is going to kind of share a bit about his experience, in regards to Elm and so forth. I tend to have a couple of people that I kind of consider as kind of experts on specific subjects. Justin would be kind of typography. I have a couple of people for like TypeScript and so forth and so forth. Gary is kind of my Elm guy. If I have any questions on Elm, whether technical or actually just in terms of the ecosystem, he's kind of the guy that I go to. So I can't think of anyone better suited to do this talk. And also I've kind of been on the fence for a very long time about Elm, and he has been trying to convince me to start using Elm. So I'm also hoping that this is kind of the talk that finally seals the deal. All right, cool. So just some quick housekeeping. As you probably know, this is Front-End Development South Africa, FEDSA. And we tend to do these talks every month. So if we have a couple lined up for the rest of the year, but if you're interested in maybe talking about a specific subject, maybe sharing some stuff, please do get in touch with us. We're always super keen to have people share kind of their knowledge. Whether they're kind of beginner level or expert, there's no kind of cap in terms of actual skill level required. I think it's usually quite good to have a diverse set of people from different skill levels. Also, just fair warning, so my office light just went a couple of minutes ago. It's kind of a bit kind of dusk evening-ish here, so I have some kind of ambient light. It's going to start looking more and more like a kind of horror scene the further we get into this talk. So just fair warning. That's not intentionally the ambience I'm going for. That is kind of due to technical problems. All right. So first and foremost, shout out to our sponsors. So let me just quickly share my screen. Cool. So doing this super DIY. So essentially, as always, kind of our two big sponsors are NML, New Media Labs. They have been with us from day one. We kind of wouldn't be able to do what we do over the last couple of years without them. Secondly, IO Digital, digital kind of design development house based in Cape Town. They kind of also drive a lot of really cool projects within the kind of product design space. Both of these organizations kind of really have been supporting us for a very long time. And I'd encourage anyone to kind of support them, kind of have a look at the type of work that they do. And, more often than not, as with anything within the tech world, everyone's always hiring. So even maybe just see if they have vacancies and so forth. All right, so cool. So with that out of the way, whoops, that isn't a sponsor. I forgot to share my screen. As mentioned, I'm not usually the guy that does this, but here we are. Cool. So then just lastly, just want to mention, if you have any questions, please ask them in the text chat. Gary, I don't know whether he maybe wants to stop at some point during the talk and kind of maybe address any questions that come up, or maybe we do all of them at the end. But as the talk goes, you're more than you're more than welcome to share questions within the text chat, and then we'll kind of address all of them and get to them. We have allocated half an hour for questions, so please, if there are any questions, please use that. All right. So then, without further ado, I want to introduce Gary. I don't necessarily want to do too comprehensive of an introduction. I'm pretty sure he'll be able to do a much better one than I can. But as I mentioned, he tends to kind of be kind of my Elm guy, and I'm also kind of we have a lot of overlapping interests. I think like we definitely also kind of tend to like also prefer kind of the functional programming side of things, and also like so I think there is some room for me to be converted to Elm here. I tend to use something called Rescript, something previously called Reason ML by Facebook, but these are kind of pretty like kind of similar in terms of their goals. So like I'm open to love. I just need to be shown the way. Cool. But yeah, so Gary, I'm happy for you to kind of introduce yourself, kind of give a bit of an overview of what you will be talking about tonight. So cool, over to you. If you just want to share your screen, I'll just add it here.
I'll just quickly get it up and running. I'm just going to share the that's so long. There we go.
Okay. All right. Okay, over to you.
All right. Well, evening, everyone. Thanks for joining. Yeah, it was Skulks asked me for quite a while now to actually talk about Elm. Eventually, we've scheduled it now. So I hope that my overview and the little bits and pieces that I'm going to show are going to be relevant and will help any of you who are wondering about the language itself. So my name's Gabe Pampara. I'm a developer, mainly focused on using Elm and Haskell. But with more of a focus on operations, research, and development, I'm one of those people who really likes optimization problems and solving them. I work for a company called CircuitHub. CircuitHub provides on-demand electronics manufacturing with instant quotes, and we do both small and large quantity orders for people who design PCBs and eventually like electronics products. So essentially on CircuitHub, users upload their design files, be it KiCad, Eagle, whatever the tool is that they're using. And then from that data, we generate a project, process all the information, and eventually have things ready in such a way that they can place an order. And within a few days, depending on the quantity and the complexity of the job and what's in the current queue, they get shipped a bunch of assemblies which are ready to use PCBs of their design. Yeah, and of course, part of the operations stuff that I do is we try and automate as much as possible in this design space. But yeah, so I think when we're going to start today, I think we should start let's start from the ground level. Okay, so we all know JavaScript to some degree or another. It's obviously one of those languages, well, it is ubiquitous on the web, right? A couple of years ago, I'm not sure if many of you remember the good old backbone.js and other such frameworks, where essentially the MVC space people were trying to explore the MVC space on the web. Rails had a lot to do with this in terms of inspiration. And of course, the two-way data binding was all the rage. At one point, the browsers defined a object.observe function or method or whatever the right term is that would obviously let you know when data changes values. But that's long since been abandoned because it was that people realized it didn't actually work or it didn't scale well enough. And it's largely gone out of all browsers these days. So Chrome doesn't have it. I'm sure, wow, who knows about Safari, but Firefox also doesn't have it anymore. So from this JavaScript, there was lots of trial and error and lots of failure, but eventually we come to React and Friends. Now, obviously this was an attempt to correct the industry path to a way that we can manage and do UI in a more conventional, less surprising way. A lot of this had to do with the unidirectional data flow, which React, to a certain degree, pioneered for most developers in terms of the idea. And of course, React is a library that just focused on the view side of things. The data side and everything else was basically left up to you. Obviously, in the space of React, components are a big thing, both stateless and stateful. And using immutable data makes life a lot easier because during the render step, obviously nothing can change. So you basically get what you expect from the render process. Obviously, JS apps should control their own state. Any state duplication that does happen eventually causes problems because you get out of sync. This is also partially part of the reason why the whole two-way data binding is actually, in a way, kind of flawed, because you can't guarantee that the sync between things is always right. You know, it does the dirty polling, especially Angular. You know, they can, it's got the concept of on dirty and things update based on that. So, I mean, the classic example is you know, the bit of code down there where you could, on the scope of Angular, just change the variable value at any point somewhere in your app. And then obviously you're going to have to try and find it. It makes things messy, makes things difficult. But obviously the framework is obviously trying to help you, but it's not always successful. All right, so, and that's when you get these strange rendering behaviors and these strange errors as well. Okay, now, I mean, obviously things moved on in life and people started to try and figure out how to manage state. We got a whole bunch of libraries in order to try and help us. Facebook obviously bought Flux. Redux by Dan Abramov came out. Essentially, we were given action creators, like the add to do function right there. Although not strictly necessary, the add to do function was that action creator. It's essentially there to prevent any form of fat fingering while you're typing the stuff out if you're making duplicates and stuff. You could, of course, create that object by yourself and just keep going. But yeah, so from these actions, you then provide it to some kind of reducer function, which is defined there as the update. So it takes the state and the current action that the dispatcher gave it, and you get back some new state, and the process essentially repeats thereof. Now, the interesting bit is that Redux was actually influenced by Elm, or at least from Elm, Redux became a reality in the Java space, in the JavaScript land. And I don't know, that was one of the first things that made me wonder, what on earth is this Elm thing that they're talking about? And that's when I started looking into this. Yeah, of course, in the Redux world, in the action creator, the type is there purely for disambiguation. And those of you that have obviously used it are well aware of that fact. Okay, so, I mean, this is just some data flow that's illustrated in a simple way, right? So there's a two-way data flow between the browser and the view, or there's the unidirectional flow where everything is a nice circle. Nothing can influence something that's behind it. And in general, it obviously makes things a lot easier. Okay, all right, so people also say like, yes, okay, fine, we've got JavaScript, but what about TypeScript, right? It's obviously, it does things better than vanilla JavaScript. The issues I have with TypeScript is that it has far too many ways to escape the type system, okay? And this is, it can be a problem. Essentially, if you're having a compilation error and you eventually lose it and ascribe the type to be any, the compiler basically says, okay, fine, I trust you. You know what you're doing, and then essentially leaves that entire code path in the realm of JavaScript, because TypeScript is a superset, right? Obviously, TypeScript is very popular, mainly because of the tooling that can be built around it. I mean, VS Code is, I mean, I don't think VS Code would be as popular as what it is now if it weren't for TypeScript and obviously the money and the backing that Microsoft has given it. But yeah, I wouldn't say that TypeScript is a perfect solution. It's a good solution given the environment. But yeah, I mean, obviously, everybody who uses TypeScript knows it's got its own problems. So it's always just something to take into account. So I just want to talk about CircuitHub's client UI for a bit. So we originally had the UI written in Angular. It was quite a large application. We're talking about close on 500K lines of Angular. I mean, obviously, that's not purely just Angular code. We're talking about, you know, CoffeeScript files, stylus sheets, Pug templates for the dynamic rendering. It was a lot of code. And the two-way data binding was eventually causing problems for the reasons I mentioned previously. We obviously went and had a look at a whole bunch of different technologies. React with TypeScript was quite prominent among the choices, mainly because of its popularity in the industry. But we also had a look at PureScript, ReasonML, known as Rescript now, and then of course Elm. So ReasonML or Rescript, it can allow you to have side effects within your code, wherever you want. You can call out to JavaScript without any problems. That, although convenient, we thought it might not be for us. Reason being that the backend is written in Haskell, and we're quite fond of the pure functional way of doing things. So Elm started looking more and more attractive. And based on the fact that the language was available, it was quite simplistic. It wasn't a general purpose programming language like what PureScript is. It's focused on the browser. We decided, okay, that's fine, because at the end of the day, we've got Haskell in the backend, so we don't really need anything more general on the front end. So we stuck with Elm. So far, it's been a good move for us. We no longer have an Angular code base. It's all rewritten into Elm, and yeah, it's become very uneventful, to say the least. Obviously, we do make logic mistakes. That's par for the course. But in terms of the actual technology, it's been, yeah, it's been uneventful. All right. So Elm, as the catchphrase on the website says, it's a delightful language for reliable web applications. Okay. Now, that's quite. There's a lot said in that one sentence. The most important thing, obviously, being that it's for reliable web applications. There are a couple of companies that are quite prominent in the Elm ecosystem that use Elm. One of them, which I think is probably the most well-known, is a company by the name of NoRed Inc. Now, NoRed Inc. is a company in the US that focuses on teaching students how to write, read, compose English and its grammar, etc., correctly. Okay, so that's basically their target market, and they're an education company at the end of the day. Now, they were one of the first people to start using Elm in a very serious fashion, and they even employed the author of the language for a period of time, although I don't think he's there with them anymore. But they had a track record, which they had for many years, where they had 0 runtime errors as a result of Elm. They obviously were integrating into some JavaScript, and the errors that were coming through were as a result of the JavaScript. But yeah, if you go online and have a look, they've got quite a good track record with regards to their system uptime as a result of Elm. Now, the language itself, it's got some features that are interesting, but they're not surprising if you're familiar with functional programming. So the language itself, it's strongly typed and it has strong type inference. It's purely functional. That basically means that there's no side effects. You can't log to the console at any time that you want. It's got clearly demarcated boundaries for how it speaks to JavaScript, how JavaScript speaks to it. All data is immutable. You can't change the value once it's been defined. However, you can transform it, and that's part of the whole functional programming aspect of the language. And of course, the big thing is that the language, it's a compiled language, right? You don't get the final build artifacts unless the compiler is happy. And Elm is, I wouldn't say infamously, but more renowned for having very good error messages coming from the compiler. And these error messages, obviously, they're tailored towards beginners in many respects. But when you start writing code that's a little bit more convoluted and stuff, it does help regardless, no matter your current skill level. The thing that throws most people, except of course if you're familiar with Rescript, is that the language itself is based on ML syntax. So it doesn't have the C curly braces, the for loops, that type of thing that you're familiar from JavaScript. So it's very different in terms of syntax. But the syntax at the same time, although being different, is very simple. There's only a few constructs that the language enforces. So there's no, once you learn them, there's no surprise. There's no exception cases to the way certain things are used. And that, of course, means that at the end of the day, most of the code that you write starts looking very uniform. Like I mentioned with the case of NoRed Inc., you're almost guaranteed to have no runtime exceptions or failures. Of course, there are exceptions where a developer can make a mistake. For example, if you create an infinite recursion process, okay, obviously the language will be fine running that, but when you run it in production, the JavaScript VM is actually going to pop, saying it doesn't have stack space, right? Which obviously is completely understandable in the realm of this. And then, like I mentioned previously, it can interrupt with JavaScript, but it does so in a very controlled manner, in a way that Elm is very, very strict to ring fence and sandbox the Elm space from the JavaScript space. So as a result, because Elm is because it's a functionally pure language, this ring fencing ensures that the guarantees and the guarantees and all the goodness that comes from those guarantees can be enforced. There's never a point where you're going to be able, where those guarantees can't be given to you. So as a result, your trust and your experience of the language starts to, it's just a better all-round experience, especially for the developer. Now, the reason why Elm is so different, well, it's partially mainly because Evan, who is the author of Elm, is a big Haskell fan. So that kind of inspired him, I guess, to write the language. But Elm is also very different to JavaScript in order to address the problems that are perceived in the JavaScript space. Like TypeScript obviously inherits everything that JavaScript has, but Elm is obviously, it's a new language. There's nothing that it's dependent on, even though the final output is a JavaScript bundle. But obviously, all potential JavaScript problems are then limited to the code emission part of the compilation process. So I don't think that's something to be too worried or concerned about. But at the end of the day, the language, it's different. Okay, now here's an example of what is referred to as the great error messages of Elm. Now, Elm is if you have to look on the web for languages that have great error messages, you probably get Elm coming up as well as Rust, although Rust took inspiration from Elm. So I would say Elm was one of the first to really take error messages onto a different level. As you can see, it's very explanatory. It's a wall of text in some ways, but it's not a wall of text that's unwelcome. It gives you the where it failed, what it was looking for, and what a potential solution can be, which is always nice. It always is willing to give you hints. So that does help. Yeah, and of course, because it's ML syntax, it's white space sensitive. So obviously there's a notice about indentation right at the end of that message. But I don't think it's too much. At the end of the day, it helps quite a lot, especially for beginners. It really helps if you start typing some syntax out and you get this weird compilation error. Usually, given the compiler output, most people can figure out what's going on, and obviously they learn from the process. So these errors come up less and less. Now, if we have to look at some syntax of Elm, you'll see it's very simple because it's ML based, right? White space means something. So in this syntax here, white space is actually used for function application. All right, so we don't need the parentheses around the parameters 1 and 2 for the function add. The space is enough. At the same time, because of this, all functions are curried, which means that you give one parameter to a function and it returns a new function. And you basically keep repeating that process until all parameters have been fulfilled. Like add 7 is a new definition. We can just add 7. That function will expect one more parameter in order to eventually provide an output. List.map map the function over a list. Concat map is a popular function. It's got different names in different contexts. This is a functional language. Okay, so at the end of the day, our friends, the monad, the functor, the applicative functor, all these things exist. Although in Elm, they're not really they're not made a prominent language feature. Okay, and at the end of the monad stuff is only there essentially because of the functionality it gives you. Okay, so in this situation, concat map so literally is just adding 7 to each value in the list, making it a list itself, and then reducing it down to a list again. And concat map happens to be the bind operation for a monad for lists, but we won't worry about that now. Okay, so that's just something just to keep in mind. These things exist, and they're very useful, especially when you start composing effects, which we'll get into a bit later. So obviously, like JavaScript, he's talking about adding pipeline syntax in whatever stage it is now. Elm already has it. Okay, so if you have a look there, you're taking the list 1, 2, 3, and then you're feeding it through to the next step of the pipeline, which is list.map, which is then fed to list.concat. Now those 3 operations obviously is the same as the concat map function line, but it's yeah, you can write your code in that way for readability. Okay. The other thing, of course, is ML syntax. They keep the type definition of a function and the function implementation itself on different lines. Like add there is a function taking 2 ints and returning an int. And obviously the definition and implementation is separated by the equal sign, like a mathematical process in many respects. Yeah. So looking at these, at the next bit of syntax, Elm has very few language constructs. Okay, so most of the functionality in the language itself is actually provided by libraries. The compiler is actually pretty stable. A lot of people have wondered why isn't it version 1.0? Elm's version at the moment is 0.19.1, and at the end of the day, it really comes down to the fact that this is just a number. It has no meaning other than what you give it, right? The whole semantic versioning stuff. Just because it's stable doesn't mean it has to be on version 1. And Evan has no real drive to release a version 1 because it's stable and functioning as is. So don't fiddle with things that work. Yeah. So in the slide, you can see that there's something called a type alias of person. That is what Elm uses to define what they call records. Records are not objects or hashes in the JavaScript space. There's no prototype. There's no inheritance of functionality from some kind of prototype chain. It is what it is. It's literally just a data container with some data values in. So obviously that person has a name, age, and potential list of children. The name person itself can be used can be used as a function as a constructor itself. So given the right number of parameters of the right types, you can get back this record. Okay. So Bob and also Bob are the same thing essentially at the end of the day. Because it is an alias, the record can be defined directly without the need to define a person. Elm uses something called structural typing, which means that it doesn't really care about things as long as the names of the properties within a record and the types match. You can pass anything with those values to a function, provided, of course, you use a special kind of syntax. If you define, for example, increment age will need exactly those all those values for person. So it knows that at the end of the day, there's a name, age, and children. And as you can see, Elm has, like many other functional languages, has a concept of creating or local bindings. So they use the let-in syntax to do that. So here we define new age as being the person's age plus 1. And that syntax with the curly braces, we have person pipe. That's a update syntax, allowing you to create a new record of type person from that operation. So it means that you can keep everything else the same. It's like the, what is it, object.assign, right? It's very similar to that. but yeah, so that's basically it. Those two slides basically cover about, I would say, 90% of the syntax that's in Elm. There's obviously a few more things. For example, imports exist, module definitions exist, but those we'll see later. There's nothing really more that you need from a syntax level in order to understand how Elm works. There are, of course, some advanced features. Like I mentioned, you could pass, I can't remember the terminology right now, but you can pass a generic record as such, saying that this function takes a record. I don't really care about all the other fields in it, as long as it has these that I'm specifying, it'll work. But we'll have a look at that in a bit. So obviously, because this is a functional language, custom data types are very important. Right there, we're defining a filter with a couple of options. I'm sure people are referred to these as union types, as algebraic data types. But I'm just going to refer to them as a sum type because that's what it is. It's three potential values, so it's but they're distinct from each other. So the nice thing about this is that we can actually say, okay, fine, we have a bunch of to-dos, like the normal to-do app that people often use as an example. You take a filter, a list of to-do, and you give back a list of to-do. You pattern match on the filter, and then based on the pattern match, you give different implementations based on your business logic. The nice thing is, if you forget a case that's defined in the sum type, the language will essentially fail to compile because you've missed something. So Elm is very restrictive in terms of you must cater for the failure case. And although it might seem tedious, at the end of the day, it makes your code a lot more explicit, which means there's less guesswork, not just now, but later. And I've thanked myself, ironically, a bunch of times because it's so explicit. Coming back to something that you haven't seen in months and seeing all the potential cases laid out in front of you makes so much of a difference. There's literally no questions to ask, no what if scenarios, because everything is so explicit. Now, we've all seen this, right? It can be a problem, but thankfully Elm deals with it in a very simple and elegant fashion. Null and undefined don't exist. They cannot exist, okay? It's just not in the language. And for that reason, we have to use other constructs to have the notion of missing values, error values, and those type of things. But that's not a problem because all we can do is define some sum types that are in the language and use those to enrich our types as we go forward. So I'm sure all of you know what a maybe type is. It's often called optional or option, depending on the language. It either has a case where a value is present or there is no value. Okay, but it's a real value. The nothing itself is a real value. It's not just some sentinel null value which we can't do anything with. Similarly, we have a result type, which is generally what they call right biased, which means it prefers okay values, okay, instead of the error value E. And because of the way the operations on result and maybe work, it allows you to define the happy path for a bunch of code. And if at any point something fails, it just stops. It essentially short circuits the execution from that point onwards. But you never have to actually physically worry about it because the data type is essentially encoding that behavior for you. One thing to note is that in Elm, much like other ML languages, anytime you see on the left-hand side of the equal sign a lowercase letter, for example, in this case, either E or A, in the case of result, or A in the case of maybe, that's a type variable. Okay, so you need to define what A is in order to use it. Could be maybe int to indicate the presence or absence of an integer, etc. Okay, so these are important types because not only do they allow us to regain what we've lost return in terms of being able to define something as null, but it allows us to ensure that our code is what they call total. You never have a case where you're returning a value that breaks the type. Okay, so for example, integers, if you return void or null from a function working with integers, you're now suddenly outside of the set of integers, and that discontinuous value can cause havoc in other ways. It basically prevents your reasoning from continuing, because now you have to consider this other value, which is outside of the set of integers. Okay, so although Elm is a language, it comes with something called the Elm architecture. Now, the Elm architecture is essentially the runtime system on which Elm code executes. And that gives you that sandboxed, ring-fenced analogy, or at least example that I gave earlier. This is, I can't remember where I got this, but it was from another Elm talk. And I thought it's quite an apt little image. Obviously, there are messages that are involved. These are actions that the user performs, clicks a button, navigates something, whatever it might be. And there's the older gentleman there called the update function, which is essentially that reducer that we were talking about in the Redux example. He hears the messages, makes a change, the model updates, and as a result, the view updates. So we've got this unidirectional flow of information coming from one part of the architecture to the next. And this is the only way Elm allows you to write code. It's essentially restricts the data flow to this paradigm of view model update, and of course the interactions from the user. This is very much the reactive pattern that everyone was going on about a couple of years ago, right? So it's, even though it might seem restrictive, in some ways it is, it actually causes the code to firstly look very uniform, and secondly, it still allows you to do everything you need to do. Okay, you just have to do things slightly differently, mainly because of the fact that the language is immutable, and that you have to generate new data from these messages in order to affect the application state. So the Elm architecture is often reduced to the acronym T. So like I said, it's completely sandboxed from the JavaScript runtime. It also means that when you create your little Hello World application or whatever it is in Elm, the initial bundle size is a bit larger because you're shipping this runtime with your program. Now, we're not talking about much. We're talking about maybe like 10 kilobytes, something around there, for this entire runtime system. But the runtime system obviously is a static size. It never ever increases. So as your code keeps growing, that will always remain the same. So it becomes very it's negligible at the end of the day, because most of the code will end up being business logic and view updates and all that stuff. Okay, so the way Elm interrupts with JavaScript, it's done in two possible ways. Okay, the first way is something which they term ports. Now, a port is essentially a client-server RPC effect system. Okay, so you would, from Elm, generate a message which you send to JavaScript. This message is encoded using JSON, and JavaScript obviously receives it on the other end as JSON and then can do whatever it wants. The reverse is also true. JavaScript can send a message to Elm, provided the port exists for them to like inject the message through the fence, and Elm accepts JSON as its primary communication data structure. However, before Elm even considers giving this data to the rest of the application, it must go through what Elm refers to as a JSON decoder. Now, this decoder is essentially there to take the JSON and convert it into an Elm type. And while it's doing that, obviously, you can do all the kind of validation, checking, all that kind of stuff can be done at the edges of your application to make sure that anything going into the more core bits of the onion, as it were, or it's valid Elm data. And from that point, you never have to worry about it again, because you validated it at the edge of the app. The other option, of course, is web components. Elm has pretty good support for web components. Obviously, you can write your web component in JavaScript, deploy it, whatever, register it in your web browser, and then Elm can literally just take that new tag definition and generate the HTML for it. You can, and then of course, attach your listeners and things to listen to the messages that might come from the web component. But again, you have to decode the JSON payload in order to make sure that you're getting the information that you expect. Okay. Yeah. All right. So the other thing that people often wonder about is how on earth does Elm actually fit? Let's say, for example, you've got a big React application, like we had a big Angular application. We didn't actually convert huge chunks of the application to Elm at once. We actually decided, okay, fine, I'm going to take this small component that's in my Angular view, and I'm going to convert just that into an Elm application. So it's quite easy to embed Elm into Vue, React, Angular, etc. And over time, obviously, in our situation, eventually Elm overtook the amount of Angular that we had. And then the reverse started happening, where we started embedding Angular, React, or whatever it is inside of Elm. Now, this wrapping process and the libraries required to do that have already been defined in the ecosystem. So you can just go and use these, import them. The React ones obviously are on NPM. Just pull it down, use it as a normal component, except you give your Elm code as the component data to the component, and it just does what it needs to. Okay, and because Elm is ring-fenced and sandboxed, you know that once that component starts, it's going to work. There's no changes about it. It'll mount correctly, all that stuff. All right. So then, of course, using these ports, you can have your React, Angular speak to Elm and vice versa. Okay. And yeah, of course, if you are going to consider using Elm at some point and you already have an established application, choose something that's standalone and convert that. See how it goes. Worst case, you can roll back. You don't have to use the Elm, you know. Just obviously, it depends on your use case and how you want to go forward. But I found that as a quick experiment to see if something will work in Elm, the cost or the development burden that comes along with it is actually quite low. So you can quickly experiment and make sure that things work the way you want it to. Right, so now that all of that's done, we can talk about the Elm ecosystem. Now, the ecosystem is essentially Elm, the compiler, the runtime system, and a bunch of tools and other websites and things that exist for developers. Now, I think the most important is obviously the package repository. It uses something called package.elmlang.org. The big benefit of Elm's package manager is that it has enforcement of semantic versioning. Okay, so although the compiler itself is on version 0.19, all packages have valid semantic versioning numbers, which means you make a breaking change in terms of the rules of semantic versioning, the package manager will refuse to release your code until you bump that major version. This obviously gets around a whole bunch of issues. I mean, at the end of the day, although SemVer has a lot of, it's good in principle, the implementation of it or the enforcement of it is something that is basically non-existent. I'll never forget a situation where underscore.js made a small little release, one of their patch versions, but it was actually a major breaking change, and chaos ensued, much like LeftPad. Probably not to that degree, but it was a problem. So at least with Elm, the packages are correctly versioned. Furthermore, the Elm binary, the compiler, you can actually ask it to say, okay, fine, I want you to tell me what changed between version X and Y for this package, and it can come back with a listing of type signatures and method names, etc., that are different between the versions you specified. So at the end of the day, it means that you don't have to go to GitHub to see what changed exactly, but it's another tool in your toolbox that you can use in order to see these things. Obviously, there's been a lot of work on the Elm language server, so all the good LSP things exist. Obviously, that means that editors and that type of stuff are varied amongst people. It's just generally a good thing, I think, at the end of the day. It makes things a lot easier for everybody. Elm also provides what they call a time traveling debugger. So I'll show you an example of it in a bit, but it essentially records model changes so that you can see how your app changes over time by applying these different models to your application. Okay, then of course there are some online tools that are available. You at the end of the day, you don't really need to use them because you get good enough at writing decoders or writing the Elm HTML, which is very similar to lit HTML. It's a bunch of functions, like everything else in Elm, it's just functions. Yeah, these tools are there to help people see the mapping between what the HTML, for example, should look like or does look like, and what the Elm would look like that would generate that HTML. But yeah, so end of the day, obviously, Elm is it's not a super widespreadly used language. So there are some deficiencies in terms of packages that are available. And in those situations, it's more than fine to wrap a JavaScript module that's available in NPM until the point where the JavaScript module becomes so frustrating to you that you actually decide to write the Elm module. So the No Red Ink guys did exactly that. Even though they had this massive Elm application, there was a portion of the application which they used the jQuery date picker because it's got a time and a date. And it was basically something that worked for them. They wrapped it for years. And then eventually one day, somebody in the Elm community actually wrote a date picker, which they started using. So then they could remove that entire dependency from NPM and move on with their lives. So it's really, yeah, even though the ecosystem might be young, I think that's probably the nicest way of saying it, it doesn't prevent you from reaching for things that are already available but are only in the JavaScript space. Okay, now I was asked to talk about how Elm is with hiring and you know, like what does it do to the company, etc. I mean, for us, Elm was a real boon because it's really simple language, easy to understand. It's got a great compiler, which means that, you know, there's less babysitting that you need to do because the compiler is effectively there helping somebody along. The compiler is essentially your free pair programming buddy. You know, it's also the gatekeeper because it means that no code that doesn't compile is going to get shipped. You know, and obviously we've got some CI jobs that run to make sure of this. But yeah, I mean, at the end of the day, it's good enough to help new people that they can get productive very quickly. Now, because of this, we had a new guy join. He was familiar with JavaScript and React, but nothing with Elm. He was writing production code in Elm within 3 days because the compiler helped him. The code, the surface area of the syntax that's needed to be learned is so minimal, and of course there's, you know, lots of resources for people to go and speak to. It's because once you write the code, it's almost guaranteed to work, barring any logic issues. It gives you a happy feeling. There's less for you to worry about because the code, you know, if it compiles, there's a high probability that it will just work. And we found that applicants on the hiring side tend to seek us out because of the fact that we use this as part of our technology stack. I don't know. It's been largely surprising, but at the same time quite exhilarating because it means that we know that the people who want to apply for work are the ones who actually want to learn the language and want to do things. So yeah, it's been a net positive, even though it's somewhat largely unknown in the JavaScript space. Okay, so here's a bunch of notes. There's various links. I mean, the big one, of course, is the guide.elmlang.org. It's essentially a little book that the author of Elm wrote to help people go through everything, ports, web components, that type of stuff, and just gives you an idea of how things work. Obviously, the awesome whatever websites exist, and there's a bunch of companies that are listed also in the awesome Elm repo that are Elm users. People would be surprised to know that Microsoft is a big Elm user, although they don't advertise it. Pivotal Tracker, which is used by a bunch of people, is written in Elm, which I didn't know. Concourse CI, their entire web front end is written in Elm. And yeah, the list goes on. Obviously, there's a lot of consultancies that use Elm, mainly because you can write the code, be done with it, and it works. You don't have to come back for whatever. And much later, if changes are required, it's quick to do because of the sureties and the guarantees that you get from the compiler. Yeah, obviously there's Discourse, there's a Slack for Elm, there's a Discord for Elm. Yeah, but obviously all of those are available on the Elm website, which you can go have a look at if you feel like. And it's obviously elmlang.org. All right. That's basically everything I wanted to talk about. I think now might be prudent for us to just have a look at some code, get a feel for how things work, have a look at the error messages that the compiler gives us, and take it from there. If that's okay with you, Skulk.
Yeah, 100%.
Okay.
Oh, sorry. I just made myself really big. Sorry, I'm learning the ropes as we go. Yeah, go ahead.
Yeah, cool. So I'm just going to share my screen once again. Let's have a look. Hopefully I can find it now. Wonder. Okay, I'm going to share my screen. Hopefully we get. Can you guys see that?
Yeah, looks good on my side.
Okay, cool. All right. So this is a little Elm application. It doesn't do much right now, but we'll go through it. The main thing to know is that, okay, fine. We're using a pretty new build tool. So we're using Vite with Elm, and that obviously gives us the nice HMR that everybody's gotten accustomed to in the industry. All right. So the first thing to note, yes, I'm using Emacs. It's amazing, and we can leave it at that. All right. So the most important thing to note here is that, first of all, this is a little bit of the syntax that exists. All right. So we're defining a module called main, like Java and other such languages. The module name and the file need to match. Anything in a subdirectory would be module name dot, where a slash would be for a file going down. Yeah, so that's basically the only restriction with regards to the module names. It's got the notion of exposing. So these are functions and definitions that are available outside of the module itself that can be imported by other modules. So right now, there's a few things that we need to have a look at. I'm quickly going to open up. So there's a JSON file which increase. So, oh dear, sorry. So this is the what they call the Elm JSON file. So this basically defines, like the package.json, all your dependencies for your current project. We're defining the Elm version, the source directories, the type, it's either application or package, obviously for a library, that type of thing. And then, of course, the dependencies. Now, the dependencies, the direct dependencies are dependencies that you can import directly into your application, whereas the indirect are the transitive dependencies of your dependencies. And then, of course, there's some test dependencies, which is simply the same thing. Elm manages this file for you, so it's not really necessary for you to fiddle with it too much, except when you're writing a package, because there's a bunch of things that the automated generation of the file does not add. But those type of things I'm not going to worry about now. If you are interested, you can either check online, ask me, whatever. But that's the only difference. But for an application like what we're doing now, it works just fine. Let me just quickly see here. Okay, here we go. All right, so we're importing the browser module. This effectively is the platform running target that we're after. We then have a HTML module. This is essentially the bunch of functions that represent the different HTML nodes that we want to render in our application. The attributes, quite self-explanatory. The events, the dot here basically means that we're importing all exposed functions into our current scope, so we can reference them without any form of namespacing. And then, of course, we're importing something called message, which I'm going to ignore for a bit. So as you can see, a double dash is a comment in the language. So obviously, the main thing is there's a main function. This main function is obviously the entry point, but from this function, Elm can basically traverse your code and determine what is actually used. Elm has a very good dead code elimination strategy. So even though you might write a bunch of code, the bundle at the end of the day is guaranteed to only contain the code that is actually used. The only caveat to that is any let definitions are not cleaned up, because you don't know whether or not they're used in various rules and situations. So those will also be included, even though sometimes that's not necessary. But luckily, there are tools such as Elm Review and those type of things that can be used for you to basically lint your code, make sure things are not present that are not used, and move on with your life. So right now, we're creating a document with a bunch of definitions. There's 4 functions: init, update, viewer, and subscriptions. Okay. Now, init is the first function that's called from your program to actually generate the initial model and any form of managed side effect that you want to have executed. Update is the reducer example that we had in the slides. View is how you generate the view for the HTML side. And then, of course, subscriptions are events that you might be listening to that are coming in from outside. However, seeing as we don't have any, we can just define that our subscriptions is nothing. Okay. Now, in this example of the code, we are using a number, which is actually just a type variable. It could you could even define it as being a, and everything will still compile, or not. Oh, all right, of course. So Elm does have a few very specific special values. Number is one of them. The other is comparable. So comparable is effectively it's a type parameter that effectively allows that it's got the equality operator defined on it. So numbers are comparable, strings are comparable. However, when it comes to your custom types, they aren't guaranteed to be comparable. Okay, in terms of at least from the perspective of Elm. Okay, and this is more relevant when you come to the container types like maps, sets, etc. They need comparisons, and Elm only allows comparable values. However, there are equivalent APIs from the community available on the packages website that allows you to have anything in these sets and things, because you can define your own comparable function that you give it when you create the container type. But I don't think that's too important. So if you can have a look here, so we basically have defined a Redux style action. Okay, it's got a type parameter. It has to be suffixed here with an underscore or something, because type itself is a reserved word. Okay, so that's why the underscore is there. And then, of course, some data, which in this case we're ascribing to be an integer. Okay, now the init function, these 2 parentheses next to each other is known as the unit value in functional programming. It's basically a value that exists but is not useful. Okay, so a lot of the time you would use it as a parameter to something that's lazy to force evaluation. Okay, but at the end of the day, all we're doing is we're saying that this init function creates a number, which is the model in this case, and then it creates something called a command or action. Okay, so commands are effects that you give the Elm runtime to do on your behalf. Okay, they aren't guaranteed to happen immediately. They get scheduled from the runtime itself, but generally it's quite responsive. So, for example, you can have a command that does an HTTP request, simple XHR to somewhere, and you would actually write it down as a command. Okay, so in this case, we don't have any commands to do, so we just give it command.none. The update takes the action, the model, and returns a new model with any actions, any commands. So in this case, we're checking if there's an increment. We increase our model by 1 if that is the case. No command. If it's a decrement, we reduce. Otherwise, we return the base case, which is keep everything the same. Okay. Our view is nothing fancy. We just create a div with some inline styling. Of course, you could create you could reference a CSS class and give it whatever name. Okay. This is failing because, so this is an example of a Elm error. It says I can't find the class variable. Gives you some alternatives, which it has in scope, but then it asks you to please go and read how imports work. Okay, so it like prompts you into the correct thing. Luckily, we know why the error is happening here, and that's because our attributes import doesn't, we're not importing the class function. Pull it in, everything's happy. Okay. This essentially is a no-op. It won't do anything to the HTML. Okay. Create an image. All HTML or all DOM nodes effectively have a tag name, a list of attributes, and a list of children. Okay, and it's given in Elm as the function, and then a list followed by another list. Of course, the nice thing is this is all type checked, right? So I can't, for example, put a text node. Oops, sorry. I can't, for example, put a text node in my attribute list, okay, because the type's differ, so it'll explode. But luckily, that's not so bad. So in this case, we've got nothing to do with these subscriptions. We don't really care. And then, of course, this hello world is defining our view over here. Nothing too fancy. One thing to notice, right here for the button, there's an on-click handler. And when this on-click handler happens, we call the increment function with the current model. The increment function is over here. Because our model is an integer, we can just generate a new model as the result. And that will then be sent to the update function, and that whole loop process happens again. Now it's quite simple. You know, you push the button, the count increases. Right over here, which can be disabled. This is the time traveling debugger. So if we click on it, we get a window popping up. There have been this many changes. So you could, for example, in a very convoluted, or not convoluted, but a very complex model, something's going wrong. You can start this up and you can start going through and just clicking on the different times. And as you do, you can see that the count value here is updated. Now, this is quite simple because at the end of the day, all that's happening is that Elm is taking this data that's stored in the debugger and pushing it through your update function, which then results in the view rendering again. So it's quite simple. There's no state that you have to worry about. You can just easily just go through this and check things and make sure things are working as expected. Because the debugger is running now, obviously the application is paused, so I can't do anything. Okay, but you can just click over here, and then everything is back up and running. And then, of course, more events are captured on the side. The nice thing, of course, which is quite cool, which we've used quite a few times, is that you can actually export the state graph. Give it to somebody, they can open up the app, open up this debugger, and they can import it again, and they can have the exact trace of what you did to break the app, which is, of course, quite nice for traceability and that type of stuff. But yeah, obviously, there's 1,000 ways in order to do that. So, but that's just one example of the debugger. So there it's back. Okay. Now, although this increment process works, it's a little flawed because this action, we've defined the data to only be an integer. Now, that's not a problem in general because, you know, this application happens to work with integers, but you would actually want to have something a little bit more descriptive. The other thing, of course, is that this if statement, although effectively operational and it's functional, it's not the nicest because you're comparing strings. Strings, by their very nature, are troublesome because, you know, you can have a typo, that type of thing. You'd rather want to have tokens and symbols and things that the compiler can enforce for you. So what I suggest is that we're going to go through this code now and we're going to convert this into using a sum type. So in order to use a sum type, generally you would just create a type, Per convention, it's called message, MSG, as a shortening. And we can say that we want a message that says increment, or we want a decrement option. Okay, so this hasn't done anything yet. We've defined it, it compiles, everything's fine. The problem, of course, is if you see our program over here, we've defined that we're using an action, okay, which is using that other structure. So we just need to change our type signature, and now everything explodes, okay, which is exactly what we want. Now, this basically happens because everywhere where we are using this current action needs to be updated. So we just change it to a message. This will continue breaking. The HTML now produces a message, as well as our subscriptions. Let's see what's here. It's still breaking because main requires that, but have we done everything? Okay, so another thing I want to highlight is have a look at this signature over here. It takes it into HTML of a structure. Okay, now this structure is essentially action. It's just fully expanded. Okay, so it allows you to define the data structure up front, or at least ahead of time, and you can use it in other modules without actually importing it. It does make your typing a little bit more tedious and all that, so it's best to expose it, but I'm just going to comment this out now so that we can isolate all the errors going through this. Okay, so this changes because we actually want a message. Okay, and then of course increment over here is no longer required. We can get rid of it. Okay, now our update over here is probably the last offender message. Okay, all right, so now it's complaining about the on-click handler. All right, which makes sense because we were using that function. We now can just use the message itself so that the types line up, and there we go. Now everything is now using our sum type except our update. So in order to make sure that things are working correctly, we can just say, okay, fine, let's change this to message. So the case message of, right. All right, okay. So we know that we're wanting to implement our increment function. Increment will then basically return a tuple based on this definition over here. The tuple is then going to be model +1, and we're not going to send anything out. Okay, so that's essentially the implementation. However, note we've defined that our sum type consists of two possible options, either increment or decrement. So the compiler is being explicit. Okay, all right, you're missing this, and this happens for all cases where you actually do the pattern match. You can obviously pattern match on everything, but in the case of the sum types, there's only X number of possible values that you can consider. Once because there is no decrement function at the moment in the code, we're just not going to do anything with it. We're just going to return the previous state, and now our code is happy. Okay. Now the nice thing about this is that we can actually say, okay, fine, which we couldn't do previously, is we can actually say we can parameterize our messages. Okay. So now increment can basically return anything we want. Okay. The only differences are that in our function over here, we need to specify what the increment value should be. Okay. So let's leave it at 1, and then yeah, we can say inc. Okay. So this inc value must be an int, but plus only works with int and float values. Interesting. Okay. And our model is still an integer, but it's because of this number case. So it doesn't know what type are you working with. Okay. Essentially, it's forcing you to be specific. And there we go. Okay. So everything will work exactly the same, and we're confident that it will because of the way Elm works. if we wanted to do something a bit different, we could just create two new buttons. Create a decrement button. Okay. So we can see it's over there. And we can upgrade this one to 10. Okay. So now we're increasing by 10, by 1, and we're reducing by none, because the only place the model can change is here in the update function. So we can make sure that we are correctly importing that, and now things will start working again. So there we go. We've now moved our code over from the action type, which was that record, to actually using messages. Now, the big benefit, of course, is that we can now see that we're correctly covering both cases of our sum type. But more importantly, this else branch doesn't even exist, because it's literally not possible to be a part of the message. So it actually reduced the code by making it more type safe. So we can just remove that, and that's it. Yeah, I don't know if anybody has any questions, but I think that's most of the stuff that I wanted to cover for us tonight.
Cool. Oh, sure. We have let me just.
Sorry, no, I'll fix it there.
Yeah, we had an infinite. We had an infinite
regress. Yeah.
Sure. That was super insightful. Like, as someone who's only dabbled in Elm, but who hasn't really gone into it that deep, I really enjoyed this, and I appreciate you getting to the question that I had about kind of the hiring process and so forth. And maybe just to unpack that a bit more, I don't necessarily see any questions in the text chat, although there is a question about whether time travel debugging works in 0.19.1.
Yep. Yeah, I'm running 19.1 at the moment.
Yeah, and it's interesting that you kind of mentioned kind of Redux. Like, it's I completely forgot about that, but yes, like Redux is kind of Dan Abramoff is pretty kind of open about the fact that he kind of just completely stole the idea from Elm.
No, he wanted something nice for the JavaScript world, right? To cater to solve this problem. So I mean, I don't begrudge him for doing it. It was actually a good thing. Yeah.
So yeah, like I think so. This is maybe more of a question. Like, so I think what I often find is, personally for me, it's not necessarily that Elm itself is not accessible, Rescript isn't accessible, even Haskell isn't accessible. I think it's kind of the paradigm of functional programming.
Yeah.
And to a certain degree as well, I feel the same way about a kind of a component-driven kind of way of doing interfaces as well, which, like, is a pretty recent development. I think up until recently, we mostly thought about kind of your traditional separation of concerns by means of technologies. So having like an entire global CSS style, I'm probably going to get hate mail for this. I always get like hate mail whenever I touch on like this concept of, like separation of concerns, and like me not being convinced that in this day and age, necessarily kind of global global behavior, global presentation, and global content by means of HTML, CSS, and JavaScript is necessarily the best way to separate concerns. But it's kind of just been kind of the way to do it for so long. But anyway, so even kind of like coming from that world to kind of this more component-driven like space where you separate things by means of components instead, like self-contained components instead of by technologies. Even that I kind of felt like, I think nowadays it has a much bigger mind share. So I guess people are just kind of forced to kind of like come to grips with that way of thinking as a part of just becoming like an intermediate front-end developer or so forth. Whereas but I think once you kind of have that, like, it's very easy to kind of transition from React to, Angular to Vue and so forth. And I find the same with kind of like Elm and Rescript and Haskell and those type of things. It's kind of like the problem is the paradigm and not necessarily the technology itself. And I find that a lot of people struggle with the paradigm itself. And maybe to kind of add onto this, it's maybe very topical. There was a discussion today on ZA Tech about kind of hiring intermediate and senior developers, and where like a specific individual mentioned that everyone he has been interviewing, so it's for a senior React position. Everyone knows how to use React and whatever, but there doesn't, he found very few candidates who actually have an understanding of what is JSX, what is the virtual DOM. They kind of know the API, but they don't really know what the thing does. And I find with functional programming, there's no way around that. You need to kind of understand kind of what the actual tool does for you to use it effectively. I think with something like object-oriented programming, you can abstract that kind of quite far away. You can have update DOM or whatever, and it just does its thing, because of side effects. Side effects allow us to abstract away a lot of complex behavior, but with that comes, pardon the pun, comes side effects. There are problems with kind of abstracting that complexity away. And I don't really kind of know. You mentioned that you guys aren't necessarily having problems hiring people, but I feel it's already quite tough actually getting developers because the field is so bottom heavy with juniors that kind of actually understand the language, the JavaScript, the language, kind of understand the web as a platform and not just the APIs of the tools that they use. Where I don't know, sometimes I feel by adding functional programming as a requirement on top of that, it's just kind of narrowing the possible pool of people that I can have contribute on my project or hire even smaller. But you're saying you don't have that problem.
Well, I mean, at the end of the day, everything on our side is functional, right? So that generally would be enough to turn a couple of people away because they're scared of the paradigm, as it were. Even though it's essentially the same, it's just a more rigorous, or at least more enforced way of doing things. Now, with us, for example, and Elm, as it were, one of the gems of Elm is that because it enforces you to write code in a certain way, all projects eventually start, I mean, not looking the same, but the code itself is, that there's going to be some place where your code gets initialized, some update, some view, and then of course from those you can split them down into different functions. But those concepts are always present because of the way Elm is structured. So from that point of view, it sort of forces people to all think the same because there's you have to work within the constraints of what the runtime system gives you. So let's say, for example, in JavaScript, people expect people to write in a functional way, this, that, the other. The problem with that is that you're layering on functional programming onto something that isn't inherently functional to begin with. So you're now asking people to not only do things functionally, but you have to ask them to be disciplined enough to make sure that they don't sneak something in because it's easier, that they keep true to the paradigm, if you want to put it that way. But like in the case of Elm now and other languages like this, it's either this way or it just doesn't work. So it removes that discipline factor from the programmer, and it essentially, it's like you don't have a choice. So from that point of view, it actually makes things easier. There's a quote by one of the by a functional programmer by the name of Runar Bjarnson. He wrote the Red Book in the Scala world, and his quote is simply, what was it? Liberties constrain while constraints liberate. And I think it's so true, because if you're constrained in that you can only use a certain bunch of tools, not because of business rules or whatever, it lets you be more free, because I can only do so much in this way. Whereas the other way around, because everything's so open, it makes your life more difficult in the end. So obviously it's a double-edged sword, but it's at the end of the day, it's what you're willing to inflict on yourself, if you want to put it that way.
Yeah.
But yeah, like if you stay true to the way React works, for example, you can have a pretty good time. Even though there's this mutation heavy world outside of your React components. But again, it's like you're restricting yourself to work with the view in one specific way. React, of course, puts those constraints a little bit more concretely down, and as a result, it makes your life within that space easier. So yeah, it's difficult. I'm fully like what's the right word? I understand and I sympathize, in those situations. But yeah, it's like because like most of the team are functional programmers, our Angular code eventually, you just want something to work. But again, you don't fully understand how the Angular side of things officially works, because it's got this massive life cycle system. And so as a result, you cut corners, because it's an impediment, but not a fun one. If I can put it that way, yeah.
No, I 100% agree. I mean, like as someone who kind of has a foot in the design world as well, like that's a whole point behind design systems, is that you don't like sweat whether something should be 11 pixels, it should be 12 pixels, it should be 8 pixels. Like there's like extra small, medium, large, and XL, and your padding can be one of those. So like, no, I 100% agree with kind of this notion of constraints. Yeah, it is a tough one. Like, it's interesting that you kind of said that you kind of consider VS Code success due to TypeScript. I tend to actually see it the other way around. I tend to see TypeScript success due to kind of VS Code, because it's built into VS Code. Yeah. So I remember, like, before VS Code, everyone was using Atom. That was kind of like the thing. But the problem with Atom is Atom was like really, really slow. I don't really know why. Both are built in Electron, but maybe just architecture or whatever. Maybe they just learned some things kind of the hard way, and VS Code could take those learnings. But the reason why everyone switched to VS Code was just VS Code was just so much faster, even though it's built on the same technologies. But I remember back in the days before VS Code, like it was very much kind of 50-50 with Flow, which was kind of the Facebook static typing tool, which I actually preferred to TypeScript. And like as VS Code took off, like TypeScript kind of just like ballooned. And I understand, because it's a mission to even set up Flow in VS Code, whereas you just get that out of the box. And even now with stuff like JS Doc and whatever, it just like automatically consumes it. But yeah, like I'm usually pretty open about the fact that I think TypeScript like as you mentioned, this is also one of those things that I get a lot of hate for. But I think you were a bit more diplomatic than I would be, in so far that any static typing is better than no static typing.
Yeah.
But I think in terms of the tooling out there, I definitely think TypeScript's the worst. Yeah. Because when it comes to static typing and kind of just being type aware, I see actually JavaScript itself as a problem, because you can do loads of crazy things. You can like plus a string and a number together, and that automatically just combines it into a string. It does loads of weird like automatic typecasting stuff, and so for me, I thought you lost audio. I assume I'm on speaker now. So for me, like, I think by making it a subset of JavaScript, like, you're kind of inheriting a lot of the problems where I think something like Rescript, or for example, like Elm. I don't know if you got any of that.
Sorry, just say that again. My battery started going funny.
No, I essentially just said, I think essentially JavaScript. I can't
hear you now. Hey.
Cool, no worries.
Let me just change this here.
Can you hear me?
Yes.
There we go. Sorry about that. Yeah, okay. My battery's not going.
No worries. Which is why, like, this is also like wireless, but which is why I use this, because I just got so tired of it. But essentially, I think what I said is, like JavaScript, like, it's just all over the place when it comes to actually the way it handles types, which means it's almost impossible to infer what a type is at any time. So, I personally think that JavaScript itself is the problem. And if we want to have static typing, then we need to not use JavaScript, something that compiles down to JavaScript. Obviously, this sentiment is shared by by Elm. It's shared by kind of Rescript, Reason, all of those. And so by nature of TypeScript being a superset of JavaScript, it kind of just inherits all those problems, because you need to have like parity. So yeah, like, I think that's kind of why I'm not a big fan of TypeScript. Like, it's not because I think TypeScript's badly designed, or like, I think it's actually pretty good for like what they kind of aim to do. But like, I think the problem itself is making it a superset. Look, I guess that's up for debate, but yeah.
Yeah, but I mean, it was obviously a strategic choice, right? I mean, they wanted the JavaScript developers. So from that point of view, it's cool. But that being said, I think like Elm is using JavaScript basically just as a runtime environment, okay? Which essentially means that all the type checking happens on the Elm side, and then they're effectively erased to go into JavaScript. Now, the irony is that's essentially how most other programming languages work. I mean, at the end of the day, when you like a native app, right? You're compiling in C. By the time it hits the assembly level, all those types are gone. So it's like, I mean, like, you can see some parity there, and I don't think it's a bad thing to have JavaScript as a runtime target. I think that's fine, and as long of course as that the code emission, or at least the final artifacts, are produced in a sane way, not by the developer, by the tool or whatever.
Yeah, I see also someone mentioned that they agree JavaScript is a problem, and also, like, just like I kind of have a bit of a love-hate relationship with JavaScript, because I primarily 99% of the time I spend like writing JavaScript, whether that's by TypeScript or whatever. I kind of I do a big talk when it comes to Rescript, but most of my work is TypeScript, just because first and foremost I'm part of a bigger team. And just because of TypeScript's like mindshare, it's a numbers game. Like, the odds of it being a TypeScript project is just like so big. And also when I'm doing my own projects, like, I can't in good faith necessarily advocate for something like Elm, knowing that they might need to continue using it, they might need to replace me, and so forth afterwards. I think it's maybe different as a contractor, whereas you're part of an internal team. And I think it's a lot easier as an internal team working on a product to say, this is what we do, this is part of an organization. If you want to work for us, you need to do this. You need to learn this.
It's also, it's very upfront. So it's like, you know what we use, and that's it. But yeah, I mean, at the end of the day, it's like, you're right, it is a numbers game. We're just lucky we chose Elm based on our needs at the time. We could very well have been using TypeScript right now. You know?
And I'd be amiss if I don't mention that, you know, JavaScript was initially meant to be kind of based on Scheme, which is a functional programming language, until the Netscape, or back in the day, Netscape. Until the Netscape kind of executives and marketing department realized that there's something to this Java thing, and this whole everything is an object thing, and they're like, the people are going to love it. Let's, in the middle of development, change it up to be an object-oriented programming language. So now we're kind of in between two worlds, which is why JavaScript's just the way it is. But yeah, so that being said, I'm curious what your thoughts are on the kind of, I did mention it in the text chat, but I'm going to ask this, on the new record and tuple types coming to JavaScript.
Well, I mean, they're very similar to what Elm provides. So on the one hand, as long, I haven't read the spec, I'll be honest, but as long as they are lightweight in terms of they don't have this massive prototype that they're inheriting from the whole time, I think it's going to be a net positive, because at the end of the day, what you're doing most of the time, you're just wanting to create a structure that holds data, and you want to be able to manipulate it, create substructures from that structure, etc. So as long as that exists in some way that's reminiscent of a flat data container, I think it's a good thing, because it's going to mean things are faster, it's less memory, all that stuff. So I think it's a net positive for JavaScript. I just don't know what the TC39 guys are going to be slapping on over and above the absolute core feature that would be the record types. Yeah.
Because, you know, we have kind of object freeze and all of that stuff, and we've gotten like libraries like Immutable JS and so forth. And it's weird. It kind of felt like Immutable JS was maybe like 4 or 5 years ago. It was kind of like in its heyday, and you just saw it all over the place. And like, it's kind of, I haven't seen it like since really in anything. I think I did some work on the Netlify CMS library at some point, and like I saw it in there, and I'm like, hey, haven't seen this guy in a while.
I mean, immutable.js, like, philosophically speaking, was doing the right thing. But I don't know if, like, especially with all the changes that JavaScript's gone through at the moment, like with I think the let and const constructs that came in, I think they don't play nice with immutable.js. So it started to lose favor. But I mean, yeah, I supported it when it came out because it was doing the right thing, TM, you know. But
yeah, and I think it's also, you know, like it's strange because at some point you definitely get, you know, like if you go deep into it enough, like you're essentially now like writing JavaScript in a different way. Whereas it almost kind of justifies becoming its own language. So I think it was maybe also stretching the limits of what makes sense as a library.
So, I mean, I just have to bring it up because it's one of those things. Now, because JavaScript is developed by committee, essentially, right? It would be really great if they would deprecate and remove some features, you know? Because at the end of the day, I've always got this like nagging vision that it's going to become very much like Java is right now. You know, like the current Java VM can run version 1 code. You know, whether or not that's a good or a bad thing is up for debate. But the point is, it can, and should it essentially.
Yeah, it's interesting. So I kind of brought up that exact point like a week ago at my talk at DevConf. So I was talking about web components, and I think there's a lot of disappointment in terms of how web components turned out. And and I'm saying this as someone who really loves web components. So I think part of it is just like it was overhyped because we kind of came from this ES6 kind of era where ES6 was this massive success, and JavaScript was really kind of like on a roll, and people were like, cool, okay, the next thing is to kind of like tackle this concept of like a component model, and everyone thought like, oh, cool, it's going to kill React and all of those things. And what we ended up getting is nowhere near that. And the reason being, like, for me personally, how I kind of view it is because of this radical commitment to backwards compatibility. You can't break the way CSS and JavaScript and HTML works. So that really constrains you. So there is something amazing about it. Like whenever I kind of introduce students to kind of the web, I start by showing them like the very first site that was ever created by Sir Tim Berners-Lee. And it's still up, and you can still view it, and it works 100%. It works exactly like it worked the day it was uploaded. And there's something magical about that, But there is also a trade-off to that. And then I think web components is kind of the point where we realize that either we are going to have to just consider kind of like build times and things that compile down to the web as just a fact of life going forward. Or we're going to have to say we're going to break this backwards compatibility.
Or the other extreme is to say, okay, fine, JavaScript was great. WASM we go,
But see, the problem with WASM is the DOM,
No, of course. But I'm just saying it's like you would need some radical shift to the next best thing kind of thing. Yeah.
Exactly. And that's also kind of the thing with WASM as well, like exactly the same. People are like, WASM, like we're literally going to be able to write like Call of Duty in the browser or whatever, or like whatever crazy thing you can think of. But the problem is, that DOM API. And that DOM API, like you can't just replace that. And like I'd be the first one to say the DOM API is a mess. But it's kind of because it is it's a massive side effect, the DOM itself, and
it's inherently mutable, right?
And that's just because JavaScript was essentially created as a scripting language. Like when it was created, like no one ever thought you'd have maybe more than 10 lines or 20 or 50 lines of JavaScript on your page. It was like, hey, you maybe just want to move this, have this button have a nice hover effect or whatever. It was never meant to be a general purpose programming language. But that's kind of where we are. And like, it's interesting. It definitely seems like TC39 is kind of just going in terms of the route where they just assume transpilation and all of that stuff to just be a fact of life. I think I have a specific note from a meeting of theirs that I include in kind of my presentations on JavaScript and so forth, where they kind of talk quite a bit about Babel. Well, this is back in the day, now, like as you mentioned, like Vite, and we have ESBuild and loads of other things. But as I corrected, like that's more close to Webpack. But the point remains, like it very much, if you kind of read between the lines, it very much seems like they are kind of just decided that this is just how it's going to be, building software on the web. Because I guess the web is really great when you kind of follow this traditional document model of kind of a document pages that are styled and so forth. But I think once you treat it as a software delivery platform, things become tricky.
I mean, it's we're there, right? We're already at the point where it's tricky. I mean, now that like what? My last pain was service workers, right? Great idea, not so easy to get right. when you're doing it yourself. So
once again, it's that backwards compatibility.
Yeah,
you can't effectively break the way the web works.
No, exactly.
You know, if service workers was something that was just like not added afterwards, it would be very different.
Yeah, of course.
Totally. Which is kind of like I almost want to say the competitive advantage that apps have is they could actually build the medium as a medium that can work offline from the start, whereas kind of a lot of this is added afterwards onto the web. But yeah, I guess it is what it is. I often joke and say, I can complain about what a mess like kind of the browser is and working in the browser is, but there's a lot of job security there. If it wasn't so hard, I might not have the job security that I do have, because I think I have a certain appetite for like kind of this complexity and confusion that maybe some other developers don't.
As long as you can compartmentalize the bits that you care about and ignore the rest, I think you'll be fine. But if you if you take everything personally and want to understand everything, you're going to probably go crazy.
100%.
Yeah.
Talking about that, like I said, I know I've met a developer once who kind of uses Haskell actually to write, essentially HTML, CSS, and so forth. Is that something you played around with?
So the project is called GHC.js. So GHC is obviously the Glasgow Haskell compiler, and it's got a JS component. It's essentially the same as what PureScript and Elm are doing. So it's using a different language and transpiling down to JavaScript. The Haskell compiler obviously is a garbage collected language, so it's got a runtime, and all they've done is they've converted that runtime to something that runs in the browser. So while it works, it's a bit iffy, because obviously JavaScript itself wants to do garbage collection. So there's a bit of a mismatch there, and I think basically the drive behind getting Haskell to work like that has dried up because of languages like PureScript, which essentially does exactly the same thing with very minimal syntax changes, but it does it much more efficiently.
And when you say PureScript, are you talking about, so my reference when you say PureScript is, I think like it was used as well to create mobile. No. Okay, so there's another PureScript. Or am I correct?
I think it's purescript.org. I'm not exactly sure. Yeah, purescript.org.
Let me see PureScript. Mobile apps. I might be confusing it with something else. That might be live. Or is it LiveScript or something? I can't. Yeah. Okay. Cool. No. LiveScript. I can't. I don't remember. But I think there's something else called PureScript that a lot of. It's kind of like, I know, big in the Vue community for actually creating like mobile apps. So obviously in React you have React Native and so forth, and Angular kind of had Ionic for a very long time. I'm probably going to kick myself when I actually now go and Google. It's probably not even called PureScript. Like, for some reason, I thought that is what you were talking about. Cool. All right.
But anyway, PureScript is another functional language, very similar to Haskell in terms of syntax and stuff, that compiles down to JavaScript.
Okay.
But it's a general purpose language, so you can run it on Node or whatever.
Okay, that's really cool. Have you ever kind of struggled with interop in terms of Elm? So I think, is it?
No, we have. So there are certain things that obviously don't lend themselves to working with ports, which has this JSON RPC kind of process. Working with files. Okay, obviously you can't go and convert your binary stream into a JSON stream in order to send it across the port. So that's a bit troublesome, but that's luckily where web components are quite handy. So the web components can obviously publish messages that you can track.
That is true.
Yeah, which you can track on the Elm side and manage your state based on that. But the actual work is done in the web component.
That is interesting. I haven't even thought of that, because web components are essentially just regular HTML according to the browser.
Exactly.
That is interesting. I've never thought about that. So do you guys actually use web components?
I think we've got one web component, but it's exactly for this file related stuff.
Yeah. So I'd actually be curious to kind of play around with kind of like web components for the actual presentational logic. And then maybe something like Elm for kind of like the business logic. Okay, that's interesting. I've never actually thought about that.
I mean, from my naive point of view right now, I think it's totally doable. I know our file upload process works pretty well. It took a while to figure out that a web component could do this, but I think it's an apt use of the technology. And the way that things marry with each other.
No, sure. And the whole point of web components is interop. Like if you look at something like Stencil, Stencil is actually its proposed use is to have interop between React and Angular and so forth, because essentially, once again, according to the browser, those are just HTML elements or HTML tags. So whatever framework you use should be irrelevant. It should treat it in the same way as it does a div or an unordered list or something. That's really cool. I've never thought about that, because to me, that's one of the reasons why I tend to kind of lean a bit more to kind of like the Rescript, like Reason ML kind of world, is like you did mention, kind of you have this escape hatch, which there's benefits and there's drawbacks to that. But one of the benefits is that like it allows a bit more interop. Okay.
I mean, like this file thing would be a complete no issue in Rescript, because you can just access the stuff directly.
Yeah. But like, there's also like it kind of gets to this point that you mentioned about kind of constraints and so forth. Like that can become an easy crutch.
Yeah.
Okay.
But again, it's like, what are you willing to deal with, kind of thing, and. So I think the bigger takeaway is that, like, regardless of what constraints you have, generally you can achieve what you need, which I think is always comforting, because it doesn't help you having this really cool technology, but it stops you at every corner, So it's like,
Okay. And with Elm, so I know Reason ML at some point kind of played around a bit with kind of like being able to run it on the server and so forth. Is Elm completely just like client-side runtime, or is there some even experimental stuff in that regard?
So officially, it's only browser-based. That being said, there are a bunch of guys who have written workarounds / things which allow it to be used in certain ways. So I mentioned, for example, there's a linting tool / code rewriting tool that's available in Elm called Elm Review. That's actually a Node application, but 90% of the code is written in Elm. So it's the fact of server-side rendering, that type of stuff, although more difficult, it is still possible. But I wouldn't say that you would get the same level of ease in doing that than what you would say from like a Vue server-side rendering app or that type of stuff. Because obviously those are tailored to do that already, whereas this is a working around what's there. So although doable, I think it's difficult.
Yeah. Well, the same thing can be said about React, but that didn't stop people.
There's actually there's an Elm static website generator called Elm Pages, which essentially does this. It does most of the rendering client side, and then publishes things that get hydrated at a later stage.
Oh, so it does hydration and stuff. Oh, that's really cool. Yeah, I'm definitely a lot more into kind of like that Jamstack world than I am in the kind of like the actual real like server-side rendering stuff.
Yeah, because I mean, let's be honest, the server-side rendering stuff, it's a lot of work for the initial page load.
Exactly. Yeah. And yeah, like I'm still not convinced. We had a talk recently on Remix, kind of React framework. I don't know. I'm still a bit on the fence, but yeah.
Yeah, I don't know. Yeah. I haven't found a place where doing some server-side rendering is really going to make a big improvement to what we currently have. Even though the bundles are a bit larger on the Elm side, the final product, you can still split them up with whatever bundling tool, rollup, whatever. So you can mitigate a lot of the potential issues. But I mean,
No, sure.
Server-side rendering beats that to such a degree that it makes it worthwhile.
Yeah, I think my general take is like if server-side rendering, like I'm getting myself in a lot of trouble tonight, but I do tend to speak quite frankly, is that if like my personal take is that if server-side rendering is that important, you should probably not be using something like React in the first place. Or you should, or you might, but like as an enhancement. Your primary architecture should probably be something that is more geared to actual server-side rendering.
Yeah.
But yeah.
You make a valid point, because at the end of the day, it's like, so React no longer becomes the primary focus. It becomes the thing that runs after the initial bit gets downloaded, made by some other process. Yeah.
Yeah, and for parts here and there as needed. Like I think this is what Smashing Magazine kind of does, although they use Preact. But yeah, I think they're using Hugo, and they just like have some bits here and there, like their checkout process and their shopping cart and whatever. Most of it is actually kind of handled by Go, just like not static pages, but kind of being spit out.
Like the old dynamic pages that were
exactly.
You know?
Cool. Maybe just to end it off, what are maybe some 3 tips or caveats or even warnings that you would give to anyone starting with Elm with no kind of like having heard about Elm now for the very first time ever?
That's a good question. I would say start small. Try and get a single thing working. For example, during the part of the slides, I mentioned that you can embed Elm in certain apps, like be it React, whatever. So find something tiny and work on that. See how it works. Worst case, you delete that code and you just restore the component that was there. Although the compiler is very easy and it's very fast and all these things, you still have to remember that you're going to have to incorporate it into your build process. Now, if you're using something like Webpack, that's fine. There's an Elm loader, all that stuff. But these are added things that can cause problems in your production code. So just be careful about that. I would also say don't try and be too fancy initially. But it's difficult because Elm also gives you a lot of it gives you that warm fuzzy feeling that everything's working. You know, if it compiles, you've got this like you're pretty sure that it's going to work. So yeah, I would say I can't give advice to say that you're definitely going to need to do these things to make it work. It's going to depend on your situation, your app, all that stuff. But what I would say is that realize that it works differently. You've got to fit into the Elm architecture way of doing things. But that being said, most of the web works that way. You know, so as long as you can work with that, you're fine. One thing that people need to be aware of is that Elm's support for web sockets is not the best. So you will have to cleanly and clearly define a port bridge to speak to WebSockets. So it definitely can be done, but it's one of those things where it's a gray area and you need to be careful. Other than that, I would say jump on either the Discord, the Slack, or the Discourse sites and just chat to people. There's lots of guys there that are sitting and asking questions. Why am I getting this type error? If you're not too comfortable with static types, use it as a process to try and get familiar with these things. Realize that at the end of the day, this functional language thing, it really focuses on data transformation. You've got some data that you want to transform in some way, and just get familiar with it before you decide to jump in. I would also say that if you want to fiddle, perhaps use something like Elm Pages or Elm Static or one of these other projects to generate, I don't know, like your blog or something, and try and see how that works before you say, okay, cool, let's go full on production. I'm not trying to scare anyone. I'm just trying to say that if you're comfortable, go for it, but realize that you're taking a risk in terms of what's already there. If it's a greenfield project, obviously it's a bit easier to make tech choices. But it's one of those things where you're just going to have to get comfortable with it. You obviously, at the end of the day, you're going to have to get buy-in from your colleagues. So talk. That's the biggest thing I can say is talk to people. Get familiar with things. Check all the videos that are online about this. There's a video by someone, I can't remember the name right now, but they basically said that I wrote my program in Elm and it cost me my job. Because
what a way to end this talk.
Anyway, this guy's a contractor, this person's a contractor, and essentially the maintenance required on this Elm app that was developed was so easy and so trivial that essentially,
I see.
They weren't needed anymore because a junior could take the code, run it through the Elm compiler, try something, see what the Elm compiler spat out. Oh, okay, make the change, and eventually, essentially, get guided by the compiler such that they got the feature implemented. Just by trial and error. So it's like, I don't know. I love Elm for the simple fact that it makes me not have to worry about stuff. Once it's written, it's written. I don't have to worry about that a refactor is going to break something. The compiler's got my back, so I can go crazy and write a massive refactor and know that, once it compiles, chances are everything's okay. It's got, be it with the tests and all that. So I would say the biggest thing is just gather information, get comfortable, and then talk to people and make a decision with you and everyone involved.
Cool. Okay, that's great advice. All right, thanks so much. Definitely went a bit longer than an hour and a half, but I think it's just such an interesting topic that I just couldn't help myself. But I think you've definitely prompted me to dig a bit deeper into Elm, specifically with the web components thing. I think you've gotten me really excited about the possibilities there.
Yeah, there's I think so. Like there's a couple of Elm conferences that are quite popular. One of these is Elm Europe. There's a guy by the name of Luke Westby who works or did work for NoRed Inc. And he has a talk where he speaks about Elm and web components, how they work together, etc. So you can have a look at that. Otherwise, guide.elmlang.org, they actually have a section on web components. So you can have a look there and just see what they're talking about.
Okay, awesome. Cool, but thanks so much for your time. Pleasure. This is really, really great. And I'm hoping we can possibly do an Elm Part 2 sometime in the future.
Yeah, sure. Just let me know, and then we can, because obviously this was very it was more of an overview, right? We couldn't get into the weeds, as it were. But if you want, I'm sure we can organize something.
100%. Cool, man. Awesome. Have a great evening, and then we'll chat soon.
Thanks, everyone. All right.
Cool. Bye.
Bye.